Hi there, I wanted to do one more quick video on how to do graphing problems without a calculator using the online app Desmos. So I'm starting with this same problem. I've already done another video showing how to do this one with the graphing calculators. So that's why it's already filled in here. The problem, it's number 12 in the 1.2 homework set. The function is up here at the top. It's about students at a country measured in thousands. And so that's the function, the 0.027 t squared and so on. That's the function that we need to graph. They gave us a specific window, which is x running from 0 to 17. I know it says t here, but when we go to graph, the graphing tools always want us to put the input variables to be x. So x runs from 0 to 17 and 0 to 300 is the range or the output values. Okay, so that gives us the window settings, and we've already decided before with the graphing calculator, we graphed it according to the window, and it was this one that's declining. According to that particular window, it starts at kind of near the top and drops until it's about halfway by the time it gets to the far side of the screen. All right, so I'm going to go to a Desmos window here. I'll have to open it. Let's see. So I was actually on. No, that's not what I want. Sorry. Try it again. Let's go to a different window. All right. So if you want to go to Desmos, you can just go to Google or the website anywhere and just type in Desmos and find the one that says calculator. Usually it goes right to the calculator, or you have choices about different kinds of screens. So just pick the one that says calculator. And it's called calculator because if you wanted to just evaluate something and not put in a function, if I just needed to know what, 17 squared is, you can actually, there's a little keyboard that pops up. You can actually type in these things and the squared is right there. I don't think it has as many functions as the graphing calculator, but you can calculate specific expressions like this just using a keyboard here, or you can use your own keyboard. If I needed to add something to it, the more you continue to type, it changes the output over here as you continue to type. So you can see your output at any time. So you can just use it like a regular calculator if you need to. But let's go ahead and put in the function. Big difference on Desmos and the calculators is Desmos needs you to put in the entire equation represented by the function. In the calculators, it just, the y equals, where it has the name of the function's output and the equal sign is already there for us. And we just have to type in the expression that has the input variable. But for Desmos, we need to type in the entire equation. And it doesn't mind if you say y equals your expression with x, or if you say f of x equals your expression with x, or function notation, or what have you. So I'm going to go ahead and put in the function notation. Now on the homework, it just said s equals. It didn't even use function notation. So I'm going to have to change my notation to use Desmos. So where it has s for the output and t for the input, I'm going to call my output f of x, and the input's going to be x. Okay, so instead of s equals, I'm going to type f of x equals. I'm just using my computer keyboard here. And then here's where I'm going to type in my expression. Notice down here, you have your variables x and y, you have your squared. If you need to do a different exponent, we have a feature for that as well. The inequalities, parentheses, absolute values, square roots, and stuff like that. It's all down here. All right, so what was the net function? It was 0.027 t squared. So I'll use this keyboard, 0.027. I have to say x squared, so I'll do x squared. And then the next term was subtract 4.79 t. So I will do subtract 4.79. I've got to use x again. And notice as I'm adding extra terms, it's changing. You can kind of see a little bit of the graph here. It's kind of changing the graph. And then plus 221.89 plus 221.89. Okay, let me check and make sure that's right. 0.027x squared minus 4.7x plus 221.89. All right, so there's the function. I'm going to go ahead and close down my keyboard now so I can kind of see it a little bit better. Now, this window was already kind of adjusted based on, I guess I had been practicing on this before. But let me show you how you can adjust a window on Desmos. That's what the little wrench tool setting is up here. It says graph settings. If you open that up, where it says x-axis and y-axis, see the inequalities where it shows X is between and you have your lower value and your higher value? That's your X min, X max right there. So if I was wanting to just make this look like a standard viewing window, like on the calculator, I would have to type in the -10 to 10 around the X. And then down here, same thing with the Y. Of course, this isn't a good window for this function, but I mean, this is the showing you kind of how you would do similar things that you would do on the calculator. And I'm just going to click out of it. So you can see that's why they didn't say for us in the homework problem to graph it on the standard window, because we can't see this function in this little area. So I'm going to go back and I'm going to adjust it to what it did ask for, which was the domain to run from 0 to 17. So that means it wants Y min to be 0 and 17 for Y max. Still can't see anything because we're not up high enough. We need to go look up a lot higher. And so for the Y-axis, it said that second interval was supposed to go from 0 to 300. Now we can start to see something. So I'll click out of here. So that looks a lot like the choice that it showed us when it had the 4 different screens. And if we were graphing it on our graphing calculators, it also looked very much like this. Here's where Desmos is kind of way better than the calculator. I manually adjusted those as I wanted to, but you can also zoom out and zoom in really quickly, or if you just hold the left click down on the graph, you can slide the whole thing around. So if I really wanted to see where the y-intercept was, I could just grab the graph and drag it over and I could see it. And another thing that's nice about the Desmos is if you click on the graph somewhere, if you hold down the cursor or the button, the clicker on your mouse, you can use it like the trace key in the calculators to just slide up and down the graph and get good estimates anyway for those coordinates for the point that's on the graph. But also notice that when you click on the graph, see how that gray button or that gray point on the y-axis, the y-intercept, is highlighted. So it goes and it tries to find the intercepts for you. If there's a turning point on the function, it will also try to find a really good estimate for that. So notice in this one, if I actually hover over that, it says the y-intercept is 0 for x and then 221.89 for y, that's exactly right. If I wanted to know, for example, it's because this is a quadratic, we'll talk about this more in module 2. I know it's supposed to have a turning point. I could do the zoom out thing and see if I can see where it's going to be turning out. I can see there it is. Right in there, it bottoms out. It looks like it might be, well, I'm going to zoom back in. So you can zoom out and zoom in really quickly, and it never actually goes below the x-axis. It gets fairly close right in there. So I'm going to just zoom way out again and see. Eventually, it starts to look like a parabola, but I'm zoomed way, way out now to be able to see that. It's pretty linear behaving in that interval that we talked about. All right, so I don't know that if I zoom back in, I'm going to get the same kind of place that I had before. Remember, we were looking from 0 to 17. I probably should just use the settings and get here quicker. That's about 0 to 17 there. So we're kind of looking about like that. Okay, anyway, that's how we put a graph of a function in. The second part, though, was about plugging in input values and getting outputs. And there's a couple of ways you can do that. I think the easiest one is if you click on the little wheel there for your settings, there's a picture of a table right there. And if you click on that, it starts to plot points for you. And the defaults is it always looks, if this is in the domain, and it will always look at the integers between -2 and +2, because a lot of times we're looking right around the origin or the x and y axis. But the problem that I was given asks for what is the estimate of the number of students for the year 2004. So since the input variable is assigned to be the years after 1990, we would just basically subtract the year we're being asked about. We'll subtract 1990 from that. So if I take 2004 minus 1990, that's 14. So 14 years after the start year. So I'd like to plug 14 into this. You can just go into the table and type in whatever x value you want, and it will spit out the y value that goes with it, 160.122. So you can do that with, this is like doing the table function on your calculator, but you just click on the tool wheel, the settings wheel, and you'll see the picture of the table, and then you can add more if you want to. You can also, I'm going to click on the second row, you can use the function notation the same way, f of 14. And notice there, it also gives you the output right there. Okay, so Desmos it's pretty quick for typing the function in. You just either type in y equals or f of x equals, and then you type in your function's expression. You can set the window settings any way you want by clicking over here, the little wrench, and then typing in your min and max around your X and Y. If you want to see different parts of the graph, you can zoom in and out very quickly. Or you can just, again, just adjust your window settings if you want to move a little more quickly. If you want to plug a number into the function, you either can use if you typed it with the function notation, you can use function notation. If you just typed it where it said y equals, it might let you do the y equals, but even if you did y equals instead, you can still do it with the table and type in your inputs however you want. Okay, so anyway, that's how we do it with Desmos. Only disadvantage to this is, like I've said earlier, we can't use this while we're testing. When you're doing your online testing, we have you shut down all of your browser windows. And since you have to use a browser window to get to Desmos, we can't use it while we're testing. So that's why I'm, encouraging you guys to find a graphing tool of some sort that you can use that does not access the internet on your testing computer. Okay, so that's enough. I will go ahead and stop the recording on that and get this posted.